Pierre Clois Thermal पे सही सिंह पश्चिमी अफ्रीकी रेंडिनेवियन लियोनी channel. You can practice more problems on this exact topic on our Padhai Karlo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is Young's modulus, the specific elastic constant that describes how a material stretches under tension or compresses under push. Let's begin. Young's modulus, denoted Y, is defined as the ratio of longitudinal stress to longitudinal strain, within the elastic limit of a material. Longitudinal stress is the restoring force per unit cross-sectional area, F over A, and longitudinal strain is the fractional change in length, delta L over L. So Young's modulus is Y equals F over A divided by delta L over L, which simplifies to FL divided by a delta L. Young's modulus has the same dimensional formula as pressure and stress, ml inverse T to the power negative 2, and is measured in pascals, or more commonly for solids in gigapascals, since typical values are extremely large numbers. Young's modulus is genuinely a direct measure of a material's stiffness, specifically along its length. A higher Young's modulus means the material strongly resists stretching, requiring a much larger stress to produce the exact same strain. Steel has a genuinely high Young's modulus, around 200 gigapascals, making it very stiff and difficult to stretch, while rubber has a genuinely tiny Young's modulus, around a few megapascals, explaining why rubber stretches so easily under comparatively small forces. Young's modulus specifically applies only within the elastic limit, the region where the material returns completely to its original length once the applied force is removed. Beyond this limit, the material undergoes permanent plastic deformation and Hooke's law, and therefore this constant linear relationship no longer holds. A genuinely classic JEE application involves finding the elongation of a wire under a known load. Directly rearranging the formula gives delta L equals FL divided by a Y, so longer wire, or a thinner wire with smaller cross-sectional area, or a wire made of a less stiff material with smaller Y, will all genuinely stretch more under the exact same applied force. A frequently tested trap involves two wires of the exact same material joined end to end, or connected in series under the same load. The STRESS and the STRAIN in each individual segment must actually be calculated separately if the wires have different cross-sectional areas. Only the applied force stays genuinely identical throughout a series combination. Also remember that Young's modulus is a genuine property of the material itself. It does not depend at all on the specific dimensions, the length, or the cross-sectional area of the particular wire or rod being tested. Let's recap. Young's modulus is the ratio of longitudinal stress to longitudinal strain, Y equals FL over a delta L, and it directly measures a material's stiffness along its length. Steel has a high Y and resists stretching, while rubber has a low Y and stretches easily. Remembering that Y is purely a material property independent of a wire's specific length or area, and that it only applies within the elastic limit, unlocks most JEE questions on this topic. That's Young's modulus. Keep the elongation formula and the fact that Y is a pure material property sharp. They unlock nearly every elasticity question in this chapter. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.